Hello, welcome to Brad Teaches CAD number 2. So, I am doing this first section quite quickly, but if you do struggle with anything I'm doing here, go back and have a little look at the first video in this series and you'll kind of catch up very quickly. So yeah, I'm going to do some revolves today, so very similar setup to last time. Part, select revolves, untick use default template. I've already got a file name revolves, so I'll have revolves 1. Millimeter Newton seconds solid, like we did last time, and very much like last time we're going to do a sketch on a plane, so that will do the sketch there, and then I'm going to show you some basic revolves that you can do. So revolves in CAD software all revolve a sketch around an axis, so much like last time we drew a sketch and extruded it out, so it pulls it out in the plane that perpendicular to the plane you're drawing on. This will revolve around an axis that you can set. So I'm going to show you first, very simple one, how to draw a sphere. So what we've done is we've sketched a circle using the circle function, and now we are creating a semicircle that sits on that axis. So by deleting those segments, we have a complete semicircle. What we can do is I have dimensioned it already, but you can add dimensions now. Hit the dimension, click the surface that you want, and hit the middle button, and you can set your dimensions. But since I've already done that one, we will accept that. So we have a sketch that is of a semicircle. As last time, I went through the extrude button. This time we'll do revolves, and I might quickly show helical sweeps as well, and maybe move on to them in the future. So once you've clicked revolve, brings up the revolve ribbon, which is similar to the extrude ribbon with a little bit more limited. So Creo is quite intuitive. It will pick up the last sketch that you drew, and then you need to set an axis. If you click you can use one of the lines in the sketch as your axis, or if you go back to the sketching page, you can add a center line, whichever one you prefer. I don't think it matters too much for this case because it's just an example. But then yeah, we have a perfect sphere within Creo, so all three axes looks exactly the same. So that's how you do your very basic revolve. Now we're going to do something ever so slightly more complicated, but still fairly simple. We are going to sketch a bolt. I'm going to do a cap head because it's the easiest to do completely as a revolve. So again, I've started sketching on a plane, and we draw the basic outline of the bolt, which we all know would look like this. Because you're doing a revolve, it's very easy just to draw the profile like that. So if you did a cross section of it, what would that cross section look like? And then we will add the dimensions in now. I'm doing these off the top of my head. So the outer face of the sort of the top of the cap head I know is 13, so that would be half of that, which would be 6.5. And we know that to get an M8 we're going to need 4 mil in this axis here, so we've added minus 2.5. Equally, if you're less comfortable doing the maths, or if you want to do for definite, you can click dimension, hit the two faces that you want to measure between with your left mouse button, hit the middle mouse button, and it will set you up there as 4. You will get this resolution box come up, and what it's saying is that you've added so many constraints that we don't know which one we want to drive this dimension. So I know that earlier I did minus 2.5 as in the distance between the top face here and where I'm going to. I can delete that one, and then this one becomes the active constraint for that dimension there. And again, as we did last time, Creo's added a lot of auto dimensions in there for me. If you don't agree with them and you want to change them, you can do it all with this constraint button here, but the auto constraints I know for this are valid. Right, and obviously this is a stupidly long bolt at the minute. Just another feature I didn't show last time, which is quite useful within Creo. You can do very basic equations in the dimensions boxes. So for example, then I did 75 over 2, and that'll make it 37.5. So for just doing things like this, I could have done 13 over 2 rather than writing 6.5. If you don't want to do the maths in your head, or you're worried of making a mistake, Creo will do a lot of that stuff for you. Again, I think this is a bit long, so I'll add that to 20. And then hit OK. And then this time, instead of extrude to make our solid model from our sketch, we'll hit revolve. And again, it comes up with the same ribbon. If you hit placement, it will tell you what sketch you're doing, and because we've already got one, it only picks one. And then what axis, revolve around the axis that we know there. So then you get the very basic outline of a cap head. Cap head bolt will look similar to this. You can obviously have it longer, and you can have threads partially way up or the full way up. But for this one, I'm going to kind of demonstrate just using this base geometry here. Right, some features that I'm going to add now to save me doing them later. It's a lot easier. We are going to add a thread to this in a little while with a helical sweep, and it's a lot easier to add these features on now, and then you don't have to worry about them later. So I'm going to do a set of rounds, which will be this face and that face there. So we've got set 1, which is that one, and we want to add a new set in here, which is this one here, and we want to change the size of that to 0.8. And the first one should also be 0.8. 0.8 is quite a common round to be left on by lathe tools, so if you're turning something, this would be a turned part in reality, then it will leave that sort of round on the edge there. It's just something to be aware of. You don't have to draw it in, but if you produce a manufacturing drawing of this and hand it away, they will try and do their best to get it flat, whereas if you leave the round on it, they're very much aware that that's what you can leave left on the bolt. And again, on the top here, because we're using a cap head, we know that it's going to have a hex head cut into it. So we'll add an extrude into the solid of the revolve. So what I've done there is selected the top face. I'm now going to sketch on it. I've aligned that sketch, and then I'm using one of my favourite functions in Creo that some of us don't have, is the palette. So we're going to add a 6-sided hexagon in here. Luckily, because I've done this all as a revolve, the centre axis, this will snap to it. And I believe that this will have, if it's an M8, it will probably have a 6 mil hex head in it, so the radius of 3, so this length here is 3, and obviously that would make it a 6 mil hex head, which is what I want there. Again, you can change these so it's aligned it to the coordinate reference system, which is what I started drawing from, and then you can select the angle of the rotation of this. So if I move this here, it'll automatically update this, but I know that I want it at 0, it doesn't matter too much, and then that's the scale, so a 3 mil rad. Then you accept that sketch, and it gives you the nice pink outline that shows that it knows that it's a solid sketch, and it can draw from that. So now we've accepted the palette, we can accept the sketch, and hit extrude. Naturally, Creo will try and extrude upwards. If you hit back and if it registers that it's going into a material, it will go down like that. And if we add a 5 mil cut into there, that will give us the hex head that we're looking for inside of this bolt. Right, there's some other features to add to the top face here. So a chamfer around the outside. So you click the chamfer button, hit the edge. I did show how to do this in my last video. And you can set the chamfer to the value that you want. So if I set 1 mil, as you can see, it's beginning to look more and more like a cap head bolt as we go. Right, now the difficult part. This is what a lot of people struggle with Creo. I have taken time over the years to learn this. We're going to add the external threads. So obviously, like I showed in the last video, if you want internal threads, like a socket or a nut, then it's very easy. You can just use the whole function, and when you do a drawing, it'll call out with the thread on it. If you did a drawing of this part right now, you wouldn't add the threads on it. You'd either have to put a note on it and leave it as it is, as symbolic, or you can add these sweeps here. So a sweep just does a profile along a guide, and that's what we're doing here. So we're going to do a helical sweep because we know that obviously a bolt is a helix feature, and we're going to set some references. So you want to define these references. So I'll ask you to select a plane. I always find it's best to select a plane that you drew on the original profile of the bolt on, which I know is that one. I did check it a second ago if you notice. And I'll hit sketch. I'll then align my drawing, and then within here it will ask me to do a sketch. And what you're doing here is you're setting the distance that you want the thread to be cut along. So the first thing I would do is set some references. These just give you some guidelines that you can work from, and all the geometry that you try and draw will automatically snap to these guides, which is what I've done there. And if you see, if I hit the solved, it says fully placed. Fully placed means that it's very happy to sketch, and it will know exactly where you're picking things up from. Right, so we'll now do a line. I know I want to sketch along here. If you stop before the end here, the threads will stop wherever the end of your line is. If you go further along, they'll crack on like that. It's very simple. Although this has got 2 red markers, which Creo says is not valid, if you just accept that sketch, it will now allow you to see that line that you've drawn on there. We now need to set a reference, which is the helix axis, so where it's going to revolve the helix around. And because we've been revolving around this axis the whole time, we can accept that and set a pitch for M8. I think it's 1.5, it might be 1.25 as the pitch, but I can't remember. Now we've set both of those. You see how this button here has come up? So what we've done so far is say, right, this is the plane that we want to draw the original bit that we're going to use to either add or remove as part of our helix, which is this one. Set an axis to revolve the helix around, so it will sweep around like this over this axis in the center here. We've drawn the distance that we want the threads to act on, and now we're about to do our thread profile. So if you hit the pen with the drawing, this means I'm going to sketch the thread. And what we'll have here is where the thread started here. We'll draw a triangle because that's what the profile of a cutout in a bolt looks like. And we've sketched it roughly, and now we will add some dimensions. So we know that obviously it's going to be an equilateral triangle in here, so I've dimensioned one side, and I'm going to come and use the constraints. So these will now say these are all of equal length. So I left click the face that I want as my dimension, click the target one, hit the middle button, and then same again with this one. And if you notice, it will automatically change that angle. Oops, I clicked on it by accident, sorry. It will automatically change this angle. Now I've asked for equal lengths here, so if we delete that because it thinks I did that, that's now an equilateral triangle in there. We can accept that profile now and zoom out, and as we can see it's started to add threads on the end there because the default setting is to add material. Now if we hit the remove material button, we'll see it will cut the threads onto our bolt. And that is exactly what we're looking for here. And we have threads in our bolt. Again, the profile I've drawn is probably a bit deep there, but it gives you a very good outline of the bolt. And what we can do is we can go onto this function here, and we can show the bolt as it is, no axis, no drawings, no points on the bolt. And yeah, that's the very basics of sort of doing revolves and your basic helix sweeps inside of Creo. I hope that's been useful for you, and yeah, in the next video I'll probably do some more sweeps, so more use of the sweep function, and I might get onto profiles and things like that, which is good for building structures. So yeah, thanks again for watching. If you want to ask any questions, either email me, my email's in the comment in the description, or you can leave a comment and I'll try and answer them as quickly as I can. Thank you very much.